Well, welcome to STS303, Lecture 1, and this is on the technology in Europe and Asia before 1500, and also Western migration of technology. The purpose of this course is to study the cause and effect of society as it relates to technology. I hope in these lectures to extract an overview of the most salient point that the authors are making in the various chapters. By way of introduction, I worked in the technical arena for 41 years, primarily in technology development, starting as a design engineer on the lunar module, which is the vehicle that landed man on the moon, to a point when I retired. I worked as vice president of engineering in a fuel cell company. Along the way, I worked on such programs as the F-14 naval fighter, which was featured in the movie Top Gun, as well as managing as senior project engineer the design and construction of the largest fossil fuel pollution control system ever installed. I hope to bring some of my experiences into the course where appropriate. Catalyst of technology development. One of the key elements in the first few chapters of Pacey is the concept of survival technology, wherein rapid population growth in areas such as China necessitated the development of technologies in improved irrigation and cultivation techniques. Survival technology is the technology required to produce food and basic necessities in order for a society to survive. That's the definition. Another theme presented is the technical dialogue that occurs when goods are traded between nations such as India and China, and the innovation and improvement of these technologies by the receiving country to suit their particular needs. Depletion of natural resources. Technological change is required when the natural resources of a region begin to become depleted, thus forcing new means of production using alternate resources. One example of this is China's Hebei and Henan provinces. As wood became scarce as a result of deforestation, and the steel industries and coal or coke became the required fuel for China's blast furnaces. In other words, due to deforestation, they could no longer use charcoal to fuel these furnaces. So they discovered that coal or coke, which is very similar, would be a suitable alternate fuel. We see this later on in this course when Andrew Darby in England discovered the very same thing. This is an example of independent invention, which we'll talk about later on, but he was a big hero in English technology for discovering something that basically the Chinese had discovered many, many years before, and he rescued the England's steelmaking industry. The next catalyst for technical innovation is the threat or actual invasion and conquest of a country. It will often necessitate changes and innovation by certain societies. To the north of the Hebei and Henan provinces, there existed the Liao Empire, populated by nomadic groups who were formidable warriors. When they threatened China's north, the Song dynasty that ruled China's heartland was forced to increase the size of their army and devote much of the steel-making capacity to the manufacture of military equipment. When the northern Song territory was invaded by the nomadic Tatars, the canal system used for irrigation was destroyed and the iron making was disrupted. The cooler and wetter northern area depended on wheat and millet for food rather than rice. The invasion by the Tatars forced the Chinese to move south, where the environmental conditions were more suitable for growing rice. The much smaller area of land forced technology to develop means of feeding this rapidly increasing population. This really is an example of survival technology now. The government was active through land reclamation to increase the size of the land that could be populated, but the most important technology development came from the importation of a faster growing rice, which meant you could harvest it twice a year, that required less water, which again was an environmental condition. And this rice came from Champa, which we would all now know as Vietnam. In a later lecture, I find this very interesting, we will see the threat of invasion or conquest as a catalyst to the greatest advancement in manufacturing technology, namely mass production. Now, how did mass production really come about in our country? Well, after we gained our independence, and again, you'll see this later on, but I just wanted to bring a feature later in the lecture forward, just to show you how history tends to repeat itself. Okay, so after we were victorious in the Revolutionary War, there was a very real possibility that the more militarily advanced countries, such as France, would take advantage and use this unstable transition to attack us. Okay, so we had to suddenly find a way to rapidly manufacture muskets to face this threat. None other than Eli Whitney, better known for his invention of the cotton gin, devised a scheme in which advanced machines, such as milling machines and lathe, could produce a component part, a small part, to exact dimensions such that they would be totally interchangeable from one to the other. Therefore, the parts would be, like I say, totally interchangeable. Thus, each musket could be rapidly mass-produced by unskilled labor rather than custom-made by craftsmen. So this is another example of technology evolving from the threat of invasion, okay? Technical dialogues between different societies and cultures, the first being hydraulic engineering. In the Persian Empire, hydraulic engineering stands out as a branch of technology that was very advanced, like China, long before the 11th century. The Romans also provided the Persians with a stimulus for further development when an entire Roman army was captured by the Persians and put to work building dams. Not only their manpower was used, but also their technical expertise in building dams. So they transferred to the Persians their knowledge of dam building by being captured and put to work. Indian trade. Around 500 AD, a major Indonesian population movement across the Indian Ocean to Madagascar introduced plant crops, including bananas, to Africa. So you had a migration from across the Indian Ocean of the Indonesians, and they introduced bananas to Africa. The lack of timber for shipbuilding in the Persian Gulf and Red Sea required Arab shipwrights to sail to South India to import teak. This provided frequent opportunities for cross-fertilization of Arab and Indian technology. Travelers from India brought ideas about architecture and irrigation to Java and Angkor. They returned to India with seeds and plants of unfamiliar crops, including herbs used for medicinal purposes. Travelers from the Islamic world then traveled to India and returned home with plants, again, that India had obtained previously from Java and Angkor. The Islamic travelers returned home from India with these same plants that are used for medicinal purposes. So we see the transfer of technology through this technological dialogue between cultures, okay? As well as not only the medicinal plants, but they came back from India, ornamental plants. One type of ornamental plant, we think of it very differently today, was a new variety of orange, okay? Islam agriculturists developed their own strains of these plants suitable for their growing conditions and ultimately export these plants, including rice, oranges, sugar cane, and cotton, into Spain. So that's how we got these plants. Ultimately, we can thank Java, Angkor, India, and the Islamic world for many types of food and material for our clothes. If we could only blame them for tobacco, that one's on us. Well, actually, the Native Americans. Okay, continuing with technical dialogue between different societies and cultures. Buddhist technology. Buddhist monks from India traveled to China around 664 AD and discovered that the Chinese soil contained saltpeter and demonstrated the blue flame when this material burned. This sparked, no pun intended, an interest on the part of the Chinese to do research that would ultimately lead to the invention of gunpowder. Other examples of Buddhist technology that was imported by the Chinese was the technique to cast large bronze statues, suspension bridges made of steel, and finally, and most importantly, the printed book. Movable type made of wood or ceramic material was an important innovation introduced by the Chinese around 1050 AD. We'll talk in a little while about the printed movable type technology. Asian perspectives. Printed technical books were readily disseminated within China, but not in Japan, India, and the Islamic world. In Japan, it was felt that printing was so closely associated with Buddhist monks that it would be restricted to religious works. Here we see how a cultural belief can delay the spread of technology. We will see this in other instances as the course progresses. Before we leave this section, there are 2 points that I would like to discuss that I find in a way ironic and in some ways humorous. One area that I found particularly interesting and somewhat humorous in light of the current oil pricing is a discussion of the distilling of crude oil that seeped up out of the ground to make incendiary weapons. This was originally developed by the Byzantine Greeks to produce Greek fire in the 7th century. It was passed on to Islamic civilizations and then by the Islamic population to the Malay Peninsula and Indonesia. The Chinese adopted this technology and were soon using fire oil in advanced weapons of their own. Wouldn't you like a piece of land that had so much oil that it was seeping up out of the ground? I just found that kind of humorous. Also, buried in this section was an item that was mentioned almost in passing, but of great interest and irony given our current green culture today. Windmills were invented in Iran and Iraq for use in corn milling. Here is a prime example of a technology that was invented for the needs of an agrarian society, and that is used today to generate clean electric power to reduce our dependency on the main product, namely oil, that the original society that invented this technology now exports. It's also an example of how a technology that was adopted by a society that modifies it and improves it to suit their own needs. So this is a recurring theme and actually the central theme of this course. Okay, let's move to Pacey chapter 2, Before the Mongols, Asian Conflicts and Contrasts. In this chapter, Pacey again discusses an invader that may not possess much in the way of technology, but still has had a profound effect on technology. He does this in 2 ways. By forcing the defending nation to improve their technology to defend their society. We saw this in chapter 1, where The Chinese had to increase and improve their steel-making capacity to defend themselves against the Tatars. More recently, the Allies of World War II had to advance their technologies and weapons, particularly aircraft, to combat Japan and to a greater extent Germany, who by the end of the war had jet and rocket-powered aircraft and the V-2 rocket that later formed the basis of our post-war space program. We'll talk about this more when I get to this period in history. So that's the first technique. First effect. The second effect is when conquered, a nation's technology usually declines and is dormant for a time until eventually it recovers. Other nations not conquered by the invader usually benefit from as refugee technologists often migrate to these nations to escape persecution. Okay, Pacey in this section is highlighting the contrast that existed between a highly evolved technology by the Chinese, Indian, and Islamic societies and a much more primitive Mongol society. The nomadic Mongol society mainly raised horses and sheep, which was ideal for their mobile society. They had no understanding or interest in farming and irrigation technology or libraries. One consequence of this was the wanton destruction of libraries and the neglect of the canal system. This resulted in the decline in the amount of food produced, most particularly in Baghdad. Baghdad was a center of technology in the Islamic world. Because of the lack of food, many of the inhabitants were forced to flee Baghdad, including many scientists. They moved west into Spain, taking their technology with them. Thus, the level of technology in the Islamic society and also the Chinese and Indian societies dropped during the Mongol occupation. Another more positive outcome was the acceleration in the level of technology in Spain and other Western cultures. You remember I said in that second point that other societies not conquered by the Mongols would benefit from the migration of technical people from those societies. As a result of this loss of technology, the societies in China and the Islamic world became much more conservative in outlook and ideology in their approach to technology for a long period of time. Excuse me. The Mongol conquest of India led to the virtual elimination of Buddhism where it had originated 17 centuries earlier. In 1194, the great center of learning at Bernays was attacked, and numerous monuments as well as books, records, and probably an observatory was destroyed. Science and astronomy was gravely affected and would not be studied again until the 15th century, so that's quite a delay. The Mongol society did possess some technology, most notably in the design of the saddle and, more importantly, the iron stirrup. This is a key part of this now. The design of the iron stirrup enabled the Mongol rider to use both hands to shoot his bow and steady himself in the stirrups, okay, so he could use both hands. This was a major advantage for both hunting, but more importantly in battle. Previously, they would use wood stirrups, which of course would fracture under this kind of load. Okay, let's talk now about fine technology. Fine technology is the term that denoted small but very sophisticated mechanisms. During this period, examples of fine technology consisted primarily of two areas, gardens and astronomy. In the first area, we find literature describing gardens with fountains as exemplified in popular literature such as The 1001 Nights, compiled around AD 850, and a book by the Benoit brothers around the same period that makes reference to a water jet that turns a horizontal turbine wheel. In 1206, an Islamic technician named Al-Jazari wrote of a mechanical device used as a fountain in which vertical jets filled a water tank, and a tipping device was used to alternatively fill this tank and the tank on the opposite side. So it would fill one tank and then tip and fill the other tank. The other area was astronomy, wherein sophisticated astronomical instruments and clocks were devised to study the rotation of the planets around the sun. One such clock was mounted at the gates of Damascus around 1100, which displayed the sun moving across the sky. In China, the most sophisticated clock at the time was built in the 1080s by a government official named Su Song, whose interest in the subject was aroused by the discovery of an error in the Chinese calendar. The clock was driven by a water wheel, 3.4 meters in diameter, with 36 buckets mounted on its circumference. The wheel revolved 100 times a day under the control of a very precise escapement mechanism. Islamic clocks were also hydraulically driven, but they weren't gear-driven like the Chinese clocks. They were driven by a weight floating in a tank. Water was slowly drained from the tank, and as the weight descended the tank, it drove a mechanism to operate the clock. It is interesting that behind all of these clock designs is the notion that if one could duplicate the motions of the sun and planets, that we would learn much about their essence. At the time, people believed that astrological forces emanated from the planets. Thus, we owe a debt of gratitude to astrology for the development of the clock. Here is another example of a technology developed for one purpose that led to its being applied to a much different and often more meaningful purpose. The years of upheaval. The technology developed before the nomadic invasion were either interrupted or terminated by invasions. In China, Su Song's clock was dismantled by 1126 when invaders conquered Kaifeng. By 1260, production of steel in the Hebei area had shrunk to 1/4 of the output produced in the 11th century, with the steel used by the Mongols to make weapons. The wider consequences of this invasion will be discussed in the next section, which is coming up now. Okay. Pacey, Chapter 3. This is the second part of our lecture. Movements West, 1150 to 1490. Around 1500, technology south of the Sahara was limited to the developments in agriculture and metalworking. There was little diffusion of technology throughout this area as the population was small and scattered into groups separated by vast deserts and unpenetrable forest. A migration of people first westward, then southward, spread metalworking and mining technology into areas rich with gold, copper, tin, and iron. This technology is thought to originate with people in Northeast Africa who had contracts with Arabia in pre-Islamic times. Powerful and extensive kingdoms were set up wherever there was an opportunity to control the trade in metals. Two such kingdoms were named Ghana, north of present-day Ghana, and Canaan. In 1706, Ghana was conquered by an Islamic army. This resulted in an influx of desert nomads whose large flocks and herds destroyed the crops of millet that the Ghanaians used for food. Many Ghanaians converted to Islam so as to have more influence with the Islamic merchants. In the Islam religion, it requires people of both sexes to be clothed from head to toe. This in turn created a demand for cotton cloth, which was an expensive import. This resulted in the importation of the technology for growing cotton and spinning and weaving techniques of the Islamic type. Here we see that a sociological, political, and religious factors caused the importation of a technology from one culture into a very different culture. Islam and Europe. Looms of Islamic design were widely used in Islamic Spain by 1177. It is from here that this technology probably spread into Christian Europe. Now, this is pretty interesting. This is how paper, which originated in China, ultimately got to Europe, okay? First of all, paper-making technology, again, originated in China and entered the Islamic world after a battle in Central Asia in AD 751 between Chinese forces and the Islamic army. Chinese prisoners of war went to Baghdad and proceeded to make paper of a Chinese type that was suitable for scribes using brushes, but not suitable for pens. Okay, so here we have a thing where this has to be modified now if we're going to use pens. The paper making technology was improved upon by sizing the paper material to make parchment, to make a parchment-like surface. This was done by the Islamic Society. By AD 900, there were hundreds of paper-making shops in Baghdad, and the demand and sales of books elsewhere resulted in paper-making technology spreading west into the Almoravid Kingdom of Morocco, where the Islamic University was located. In 1085, the Almovarids were called upon to move troops into Spain to assist the Islamic community in repelling the Crusaders after the fall of the city of Toledo. The force from Morocco halted the advance by the Crusaders. Toledo became the center of learning where Islamic and Jewish scholars worked with Christian Europeans. The increasing level of academic activity resulted in the increased use and demand for paper. This is in Spain now. The result was that a paper mill was set up in southern Spain by 1151, and from Spain, from here, paper-making technology spread to other parts of Europe. So we find, again, from a war, from capture of the Chinese by the Islamic Society, the technology spread there, and due to a threat of attack, troops had to be moved to try to defend the area around Toledo, which had already fallen. So they brought their culture there and the technology, etc. And ultimately a paper mill was built in Spain, and from there, of course, from Spain, the technology spread to the rest of Europe. The fall of Toledo in 1085 was of great significance for Christian Europe because Christian scholars gained access to Islamic technical books on Indian medicine and Hindu numerals, as well as Arabic versions of Greek mathematics. There were also books on mechanical devices, including astronomical instruments and several types of water-driven clocks. Mechanically minded Europeans became quite interested in clocks at this time and benefited greatly from Islamic clock technology. In fact, when the first successful weight-driven clocks were built in Europe around 1300, several Islamic features were incorporated, including gear wheels and epicyclic gears. Unfamiliar foods found in Baghdad cookbooks became the stimulus for new food processing techniques, most notably in the making of pasta in Italy. I found it hard to believe that pasta originated in the Islamic culture, so I Googled it. I Googled pasta origins, and sure enough, Here is what I found, and this is a quote from Google. Greeks and Romans had a flattened dough that was roasted rather than boiled to form something like pizza. Pasta, however, which is noodles cooked by boiling, came from Arabic origins. Pasta was subsequently introduced to Italy when Sicily was conquered by the Arabs. Again, we find, one society conquers another and there's a transfer of technology. I find this all very interesting. Europe in 1150, in terms of the use of non-human energy, which is crucial for technology development, was the equal of Islamic and Chinese societies. In terms of the breadth and the complexity of technology, however, Europeans were still somewhat backward compared with Islamic and Chinese civilizations. They therefore benefited greatly from their contacts with the Islam nation. Here we see the spread of technology through the conquest of the Islam nations by the Crusaders and vice versa. Much of the technology that we take for granted today has roots in the Islamic society. So we owe them a great debt of gratitude for the origins of much of our technology. Okay, the Mongols and gunpowder. In 1150, there were 3 countries that were mechanically minded: China, the Islamic countries, and Europe. As mentioned above, European technology was not as advanced as either China or the Islamic nations. Between 1150 and 1450, European technology advanced at a much faster rate than others. There were 2 reasons for this. Excuse me. The social and political institutions in Europe encouraged technology development and spread this task among the smaller states that made up Europe. The Mongol conquest of the Islamic world and China had left them with an attitude of conservatism and caution towards technology development. So the Mongol conquest slowed their technology development at a time when Europeans were accelerating theirs. Europeans experienced a Mongol invasion also, but unlike the invasion of China and the Islamic societies, the overall effect was beneficial. Namely, it improved communications with China. A European traveler named William of Rubric visited the Far East, and particularly India, and returned in 1257 with reports of gunpowder technology. Within a year, there were reports of experiments with gunpowder, and rockets were used in a battle with Cologne. What's not mentioned here, it's mentioned later on, is the English, then of course after the Battle of Cologne, attacked none other than India with their own weapons, own weapon design. It's curious how these things happen. They get the technology from India and then use it against them shortly thereafter. Chinese invented gunpowder around AD 900, and by 1150, they had invented rockets. About a century later, they developed a gunpowder mixture that produced a violent explosion. Islamic nations possessed gunpowder technology by then in the form of grenades, incendiary devices, and petroleum-based Greek fire. Remember, we mentioned the Greek fire. They used these weapons in 1249 with great effect during the battle with the Crusaders in Palestine. The Mongols during the 1250s used whole armies of Chinese engineers to operate catapults during the assault and capture of Baghdad. I find it interesting how we continually see a repetition of the same type of sociological behavior, namely the transfer of technology through the capture of members of one cultural group and the forced use of that culture's expertise either as artisans or fighters in the battlefield. We saw this in Chapter 1, where the Persians captured a Roman army and used their expertise in hydraulic engineering and putting them to work building dams. We also found it in this section on Islam and Europe. In that section, mention was made of the capture of Chinese citizens by the Islamic nation and how their expertise was used to advance the Arabs' technology in papermaking. Finally, we see the Chinese again being forced to serve in the Mongol army, using their technology to design and operate catapults. Further, Pacey describes 5 men from Iran and Iraq who introduced a new type of catapult to the Mongols and who served in their army. No mention was made whether this was by force or not. It was probably by force. Gun technology. Although there were no records of guns being made before 1280, 2 ingredients necessary to make guns did exist. They were the high nitrate gunpowder and also metal barrels to ignite the mixture. The predecessor to the gun was the fire lance around 1260. It consisted of a metal or bamboo tube in which a mixture of low nitrate powder, toxic chemicals, lead pellets, and pottery fragments were packed. When ignited at the mouth of the barrel, it spouted flames and sparks for about 5 minutes, much like a Roman candle. It seems to be intended to scare the enemy more by the pyrotechnic show and noise, and perhaps some random flying pieces of pottery that might hit someone rather than an actual gun. Unlike the fire lance, guns used high nitrate powder rather than low nitrate powder. They were ignited at the base of the barrel, and they would explode suddenly, expelling the entire contents of the barrel. The transition from fire lance to gun is first recorded in 1288. Chinese soldiers under Mongol command, here we go again, went into battle. The guns had a thickening of the walls of the gun barrel at the ignition point at the base of the gun. Early European illustration of guns around 1326 showed a similar type barrel, with the gun mounted on a bench firing an arrow. This was a common practice for the Chinese to fire arrows from guns before shot became widely available. It is thought that gun technology passed from China to Mongol-occupied Russia and then to Europe. Europeans expanded the gun technology to develop the first cannon in 1326. That was the first European development in technology, was the cannon. The diffusion of technology. The Mongols seem like an interesting bunch. First, they totally ignore the potential of the gun, as they felt it was too inaccurate and cumbersome to be fired by a horse-mounted soldier. As a result, during the Mongol occupation of Russia, China and the cavalry-oriented Persia, gun technology development had languished. Then, because the Mongols had no expertise in administration, they either let the local officials administrate their local area, or they tried to obtain administrators from other countries. They also had no expertise in technology and often brought in assistance from other countries. They let the Persians run their country, but didn't trust the Chinese to run theirs. They hired Persians, Arabs, people of Turkish background, and even Marco Polo to high administrative positions in China. They even tried to persuade the Pope to send 100 trained men from Europe. Chinese were used by the Mongols to repair the irrigation system in Iran and in Russia, also to assist in census taking and collecting taxes. Thus, the interaction of one culture with another, forced or otherwise, fostered a transfer of technology between societies. The transfer of technology often involves modification to suit the new conditions and leads to a totally new invention. An example of this is the transfer of gun technology from China via Russia to Europe. That led to the invention by the Europeans, as we mentioned, of the cannon. Silk reeling technology originated in China, migrated to the Islamic world in areas including Tunisia, Sicily, and Grenada in Spain, From Spain and Sicily, silk reeling technology migrated to the rest of Europe. The technology needed to be adapted to the twisted thread previously mentioned earlier in the chapter. The Europeans used twisted thread for strength, whereas the Chinese didn't twist the thread. They wanted it softer and more lustrous. Okay, and therefore, because the Europeans twisted the thread, a machine for twisting it had to be invented by the Europeans. Excuse me. Okay. A European technology explosion. There was a tremendous momentum for invention and technology development in Europe around 1300. Some projects were particularly important to Europeans on a somewhat mystical level, including clocks, as mentioned earlier, and certainly the spiritual aspect of building the magnificent cathedrals with their challenging structural problems. I remember that while I was on a business trip in Paris, visiting the Notre Dame Cathedral, which is famous for its flying buttresses. You can see them in the picture on the slide. Was at the time a unique architectural feature. This feature was not part of the original design, however. It turns out that while the walls were being constructed, they had a tendency to crack due to the outward forces of the roof. Okay, because of the late stage of construction, the only solution was to add external reinforcement in the form of braces, which are called buttresses. And as they say, the rest is history. Also, there's a mention in this chapter about the similarities between church bells and cannons. Some of those include they're cast from the same metal, they use the same casting techniques, and they're also used both cannon and church bells are used to signal the start of battle. So those are three similarities between church bells and cannons. I think he's reaching a bit when he states that the early deployment of cannons were mostly used to make noise and scare the enemy. They were a very effective siege weapon to bring down castle walls. He postulates that the only purpose of cannons in early use was to make noise, and that if a cannon were silent, it would never be used in warfare. I cannot agree with this theory, because if cannons were indeed capable of bringing down castle walls during a siege, whether they made noise or not would not be of any consequence. In fact, if they didn't make noise and either sent down cannonballs hurling towards the enemy or brought down castle walls silently, I contend that, in fact, it would be a even much more frightening weapon. The B-2 stealth bomber is a terrifying weapon because it has almost no radar signature and you don't hear it until it's passing right overhead. Watch the following video and see if you agree. Most of the noise you hear is either wind noise or whatever is going on elsewhere in the show. Now we'll discuss 14th century trauma. War stimulated demands for weapons, which in turn stimulated innovation. In 1356, the Mongol emperor was expelled from China by a cohesive group of rebels using cannons. As noted earlier, the Mongols neglected this area of technology, and this era ultimately led to their downfall. Mongol soldiers in northeast China and also Russia contracted bubonic plague, and it was subsequently spread throughout China in 1331 and again in 1353. The population of China decreased due to the plague from 123 million in 1200 to only 65 million in 1393. That's an enormous decrease. The plague spread from Russia throughout Europe, and by the middle of the 14th century, the population of Europe had decreased by 20 to 30%. In Europe, the plague caused the people to turn to religion and mysticism. They were suspicious of people with alien ideas and certain minority groups. Jews were persecuted, as they would be many times over the centuries to follow. We all know about that. In China, there was a turn towards introspective Neo-Confucianism. Minorities, particularly Muslims, were viewed with suspicion. During the Mongol occupation, non-Chinese officials and local collaborators carved out large estates for themselves during the forcing the former owners to work the fields and sometimes being left to starve. After the Mongols were expelled, local officials, disgusted by the way farmers were treated, turned towards Confucianism, which is concerned about the welfare of the agricultural community on which Chinese life is thought to depend. This resulted in a conservative attitude toward trade and technology and an emphasis on agriculture and basic production. With the establishment of the Ming dynasty in 1368, the Ming capital was settled in Beijing, and coastal shipping was required to bring grain from the south. There were over 2,100 seagoing vessels built by the government. Built by government shipyards, between in the 16 years from 1403. The early Ming years saw a high level of technology development, including the first Chinese cannon made in 1356, which had a cast iron barrel, unlike the European cannons that use bronze barrels. In addition to improvements in shipbuilding techniques, chain suspension bridges were rebuilt and the Grand Canal was constructed in 1411. After canals were used to ship grain to Beijing, seagoing ships were no longer needed. Further, the Navy fell out of favor with the government. There were several reasons for this. First, the Navy was associated with disastrous adventures and an impediment to trade. Secondly, some officials responsible for the Navy were Muslims, which many associated with the Mongol-appointed administrators. After 1413, shipbuilding resources were diverted towards the building of canal boats, and by 1435, shipbuilding in China was completely halted. There were no further need to further develop shipbuilding technology, as naval activities all but ceased, and there were no ocean-going voyages. We'll see what resulted in that. China became more introspective, and work on technology improvement in mathematics, clockworks, and guns ceased. This attitude towards isolating the country from others probably stemmed from the experiences with the plague and the Mongol occupation a century earlier. Indeed, there were still Mongol armies massed at China's northern border, which was the stimulus for rebuilding the Great Wall of China. The rebuilding of the wall consumed much of the country's resources that could have been used for technology development. While China was building these static fortifications, Other nations were working on technology development in the areas of shipbuilding and guns. So again, as we mentioned before, China, India, and the Islamic society became much more conservative, while Europe and other societies really ramped up their shipbuilding and gun technology and other areas, clocks, that sort of thing. These were the means by which nations achieve world domination, disproportionate to their populations and resources. The British Royal Navy, for instance, which was a disorganized group of king's ships during the Middle Ages, became a standing navy during the 16th century. The Spanish Armada sailed from Spain against England in July 1588. Okay, as I mentioned before, we would talk about the technology of movable type, which of course is a very, very important technology advancement. All of the technology development was not halted, however, as work proceeded in China on developing movable type. The Koreans first invented movable type perhaps as early as 1234. The Koreans cast their bronze type in sand molds. The Chinese developed movable type was probably independently invented due to their isolationist attitude at this time. Similarly, European movable type, which came into being around 1450, was independently invented due to their emphasis on quality production of much smaller movable type. The Portuguese caravel. Unlike China, Europe was quite busy pushing the technology development of ship design. This was particularly true of the Portuguese who developed the caravel. The advantage of this little ship was that it could make decent headway against headwinds. This enabled the Portuguese to sail home after exploring the west coast of Africa. Now, bear in mind, the Chinese by now had withdrawn their fleet, which opened up the path for the Portuguese to explore Africa. In 1443, the first contacts were made with the Negro population, and 30 years later, the west coast of Africa was fully explored and forts were set up at strategic points. Unfortunately, as we often see in history, oppression of minorities reared its ugly head, and slaves were taken to work as agricultural workers in Portugal and Madeira, and later on we know they came to our country. In 1448, the Cape of Good Hope was reached, and a decade later, Vasco da Gama sailed around the Cape to reach Mozambique. With the help of an Arab pilot, he was able to proceed on to Mombasa and Mandalay on Africa's east coast. Another pilot helped guide Vasco da Gama across the ocean to southern India. Ironically, the Chinese had visited these ports some 60 years before, but because they had, by choice, isolated themselves from the rest of the world, they ceased visiting these ports altogether. Western Europe's route to India was then now open. That's the significance of China deciding to isolate themselves from the rest of the world. Fortunately for us, a fellow named Columbus had a misguided theory that he could take a shortcut and travel in a westerly direction from Europe to reach India. We'll discuss this further in a later lecture. Well, that's it for this week. I hope you have a great week, and we'll talk to you soon.